everybody, happy Tuesday. We're going to go through our second lesson today in Unit 8. So we're going to be talking about similar figures or similar polygons. So what are similar polygons? Two polygons are considered similar when a dilation maps the pre-image to the image, or perhaps a composition of dilations and rigid motions. Similar figures have the same shape, but not necessarily the same size, which is true of dilated figures as well. So two polygons are considered similar when their corresponding angles are congruent and corresponding sides, that should be, are proportional. So just like we had congruence statements, we are also going to be seeing in this unit similarity statements, which state that a figure is similar to another figure. So the symbol for similar is kind of like the little squiggle we put on top of a congruency symbol without the equal to underneath of it. So that symbol means that triangle ABC is similar to triangle DEF. And what that means again is that corresponding angles are going to be congruent. And just like when we talked about congruent triangles, order of the letters tells you what vertices correspond to one another. So A and D correspond to one another. So A and D are both 50 degrees. B and E correspond to one another. Angle E and angle B are both 70 degrees. C and F correspond to one another. C and F are both 60 degrees. So in similar figures, corresponding angles are congruent and corresponding sides are proportional. So what that means is proportional means equal ratios. So if I were going to pull out corresponding sides, so I know that AB is going to correspond to DE because they are both the first two letters in the triangle names. So I'm going to set up a ratio. This whole unit is going to be about ratios and proportions. So I'm going to set up a ratio comparing corresponding sides. If I look at the figure, AB has a length of 10 and DE has a length of 5, which would reduce to 2/1. If I took another pair of corresponding sides, so BC last two letters, EF last two letters, I know that those sides correspond to one another. So I'm gonna look in the diagram. BC's length is 8, EF's length is 4. If I reduce, that also gets me the same ratio, 2:1. And then if I pull out the last pair of corresponding sides, which would be AC first and last letters and DF first and last letters. If I go into the picture, AC has a length of 12, DF has a length of 6, and that would also simplify to 2/1. So because these ratios all simplify to the same thing, we would say that these side lengths, corresponding side lengths, are proportional. So in the next example, I give us similar figures. These are similar quadrilaterals. And I want us to list out all the pairs of congruent angles and write a proportion that relates the corresponding sides. So the angles are going to be the easier part. So I'm just going to go through the order of the letters. So angle N, first letter, has to be congruent to angle U, first letter. Angle P would have to be congruent to angle V. Angle Q would have to be congruent to angle S. And angle R would have to be congruent to angle T. So corresponding angles are always congruent in similar figures. It's going to be the sides that are a little bit different than our last chapter on congruent figures. So in similar figures, corresponding sides are proportional. So I want to make ratios with corresponding sides. So I'm going to take the first two letters over the first two letters in the second quadrilateral. So I've created a ratio of corresponding sides. And whatever this ratio is should be equal to the ratios of all of the other pairs of corresponding sides. So now I'm taking the middle two letters, creating a ratio. I'm going to create what we call an extended proportion. So I'm just going to, I know usually when we have a proportion, we only see one equal sign. I'm just going to continue it. So I'm going to put more than one equal sign to show that we have more than two equal ratios. So now I'm going to write down the last two letters. And then the last pair of proportional corresponding sides would come from the first and the last letters. For the example next, we are going to verify that we have similar triangles. So I want us to verify that triangle GEF is similar to triangle NML. So the first step is to figure out if all of the corresponding angles are congruent. So if I look at the diagram, I know that angle G is congruent to angle N because they both have the same arc with a tick mark on it. And that was kind of given because of the markings from the picture. I also know that angle F is congruent to angle L because they have the same arc mark on it. And again, that was given to me basically because I had those markings in the picture. Now, can we say that the last pair of angles are congruent? And we can. I know that they don't have a marking on them, but we talked about a theorem last chapter called third angles theorem that says if we have two triangles and two pairs of angles in those triangles are congruent, the last or third pair of angles have to be congruent by third angles theorem. So yes, all corresponding angles are congruent in the two triangles. Next, we want to verify are corresponding sides proportional. So I'm going to take a look at the order of the letters. So I'm going to compare first GE to NM. And I'm going to look in the diagram and I'm going to figure out what is GE's length. Well, GE has a length of 12. NM has a length of 20. If I take out the common factor, which is 4, I get 3/5. So I want to verify that all of the remaining corresponding sides are proportional and simplify to a ratio of 3:5. So I'm going to look at the order of the letters again. And next,